Hi everyone. Now we are going to discuss about enzyme inhibition. It is one of the part of enzymes topic. So let's see what is an enzyme inhibition and how it is going to be important in biological systems. The activity of enzymes can be reduced or stopped by molecular agents called as inhibitors. There are certain inhibitors which are going to inhibit this enzymes. So that's why we call it as enzyme inhibition. And inhibition of enzyme action serves as a major control mechanism in biological systems, and therefore the study of enzyme inhibitors provide valuable information about enzyme mechanisms and also help in defining important metabolic pathways in biological systems. So this enzyme inhibition action can be studied under the main headings called as reversible and irreversible inhibition. So first of all, let's see the definition of the enzyme inhibition, then what is an inhibitor, and then we'll move on to the types of enzyme inhibition. So coming to the definition, the process of decreasing the activity of enzyme by reacting with inhibitors is called enzyme inhibition. Then what are these inhibitors? Inhibitors are the substances which tend to decrease the rate of enzyme catalyzed reaction. How it is going to decrease? By reacting directly with the substrate or cofactor for enzyme substrate. Either it can directly attach to the substrate molecule or the cofactor for the enzyme substrate. Whatever it may be, this is going to decrease or stop the enzyme activity. So that's how it is called as, the agent is going to be called as inhibitor. And these inhibitors may be an organic molecule or inorganic molecule in nature. Then examples of these inhibitors comes as drugs, antibiotics, toxins, and even some antimetabolites or natural products of enzyme reactions can also act as a inhibitor molecule. So that's how, if these substances are going to react with the enzyme and decreasing the activity of the enzymes, then we call it as enzyme inhibition. Now, this enzyme inhibition is going to be studied mainly under two headings. One is going to be called as reversible inhibition, and the second one is going to be called as irreversible inhibition. The reversible inhibition is a temporary one. Okay, that means it is not a permanent one. Though enzyme activity is going to be stopped, we can get it back to the normal activity. So that's why we call it as temporary one. Whereas irreversible is a permanent one. Once the inhibition is occurring, we can never get it back. So it's a kind of suicide where we cannot get the life back. So that is going to be the irreversible inhibition. The binding of inhibition to an enzyme, sorry, here it's inhibitor to an enzyme, forms an enzyme inhibitor complex. This enzyme inhibitor complex can be again dissociated into enzyme and inhibitor by catalysis method. So if an inhibitor is going to bind to an enzyme, then it forms an enzyme inhibitor complex. Now, there will be no activity of the enzyme. But if you are able to dissociate the bond between this inhibitor and the enzyme by some catalysis method, so obviously the enzyme can retain its enzyme activity. Okay, so the examples or the types of this reversible inhibition are going to be of non-competitive inhibition, competitive inhibition, and uncompetitive inhibition. So this is how the reversible inhibition is a temporary one, and we can get the activity back. Then irreversible inhibition, this type of inhibition, that is enzyme inhibition, is permanent. So where you cannot retain the activity of the enzyme back, so obviously it's a permanent one. And we cannot separate. Why we can't get the enzyme back means we cannot separate the enzyme inhibitor complex by any catalysis method or any dialysis. So examples are the iodoestate and some oxidizing agents which are acting as a irreversible inhibitors. Okay, irreversible inhibitors. Then coming to in detail study of this irreversible inhibition, we are going to read. Okay, we are having majorly of non-competitive inhibition, competitive inhibition, and uncompetitive inhibition. Along with that, we are also going to take another type of enzyme inhibition called as feedback inhibition or allosteric inhibition. Okay, so these are the different types of enzyme inhibitions that we are going to discuss in detail, all of these things one by one. So the first one is a competitive, the second one is a non-competitive, the third one is uncompetitive, and the fourth one is allosteric or feedback or end product inhibition. So let's see the first one, competitive inhibition. So here in this competitive inhibition, so the name itself is indicating competitive. So competition is always being between the two equal opponents, isn't it? So then only we call it as a competition. If we take an LKG students and a PG student, we cannot keep the competition between those two students. So obviously the competition always going to be in between the two equally having the strength of opponents. Okay, so here we are going to have a competition between the two things. What are those two things? One is the substrate and another one is the inhibitor. For what they are going to fight or competing is for occupation of this site, which is called as active site of an enzyme. So the enzyme contains a site where a substrate goes and binds is called as an active site. So this active site is going to be occupied either by substrate or inhibitor depending upon their concentration, all the things. And now these two are going to fight for the occupation of this active site, and which one wins, that will be the result of it. If the substrate wins, our reaction will occur. If the inhibitor wins, obviously there will be no product formation. So that's what this competition is going to occur, and that's how we call it as competitive inhibition. So it occurs at the active site of enzyme. As I told you, competitive inhibition is due to the binding of inhibitor molecule to the active site in place of this substrate molecule. And one more important that we have to remember here is the substrate, that means the competitive inhibitors are similar in shape. That means here if you see the substrate and here the inhibitor, they are similar in the shape. Okay, and the degree of inhibition depends upon the relative concentration of the substratum and the inhibitor. If more the substrates are there, the inhibition can be negligible. If more inhibition is there, obviously we didn't get the product because of not having any enzyme activity. So to reduce this inhibition, that is competitive inhibition, obviously increasing the concentration of the substratum will decrease the inhibitors, and that's how we can have our product formation or the enzyme activity. The best example to explain this kind of competitive inhibition is malonate is a competitive inhibitor of succinate dehydrogenase enzyme or succinic acid dehydrogenase enzyme. These malonic and the succinic acid dehydrogenase, that is SAD, is going to have the 3D structure in similar nature. So actually this succinic acid is going to, that is succinic acid dehydrogenase, is involved in the conversion of succinate to fumarate. Suppose if this, instead of this SAD, that is succinic acid dehydrogenase, malonic acid, which is an inhibitor, comes and binds to this enzyme. So obviously what happens, there will be no conversion of succinate to fumarate. So like that only, another example is sulfonylamide, which is structurally analogous to PABA. PABA is a para-amino benzic acid. So that's how the competition inhibition is a type of enzyme inhibition where the substrate and the inhibitor are similar in shape, and they compete for the occupation of this active site of enzyme. Okay, then coming to the non-competitive inhibition, the name itself is saying non-competitive. So here there will be no competition between the enzyme active site for what we call it as substrate and the inhibitor. Then why you are calling it as non-competitive inhibition? Yes, here the inhibitor is not going to compete to occupy this active site. Then for what it is going to do, how it is going to inhibit the enzyme activity, let's see here. In general, enzyme substrate forms enzyme substrate complex and gives rise to enzyme plus product. And again, this enzyme will go on bind to another substrate molecules and the reaction will continue. For example, if this enzyme is going to have the binding of this inhibitor then you are going to have the formation of enzyme inhibitor complex. Now it can form the substrate, that means it can bind to, that means the substrate don't know that an inhibitor is there, and this substrate will come and bind to the this enzyme active site already, which is an enzyme inhibitor complex. Now the substrate comes and binds. Now it became an enzyme substrate inhibitor complex. From this you won't get any product. Okay, and at the same time the inhibitor can also bind after the enzyme substrate complex also. So in both the cases you are not going to have the formation of product, that means enzyme activity is going to be lost. So that means in the non-competitive inhibition, both the inhibitor is going to bind either to the free enzyme or to the enzyme substrate complex. So here the non-competitive inhibition is such a reversible inhibitor binds to an enzyme whether its active site is occupied by the substrate or not. Either the inhibitor binds with either the enzyme or the enzyme substrate complex. So this is what. So the inhibitor, that means non-competitive inhibitor, can bind either to a free enzyme like this, or it can bind to an enzyme substrate complex. Remember, this is the step where it differs from the next coming uncompetitive inhibition. Okay, so here in the non-competitive inhibition, the inhibitor can bind either to the free enzyme or to the enzyme substrate complex. The best examples of non-inhibitors are cyanide azides and heavy metals such as mercury, or you can have the lead. All these comes as a heavy metals which are acting as non-competitive inhibitors that combine with or destroy essential sulfur hydride groups or the metal component of the enzyme. So when an enzyme is going to have this one, that is of enzyme substrate inhibitory complex, where we this call it as dead end complex. So that means it cannot be reversible. Since the inhibitor binding site is not identical to the active site, nor does it modify the active site directly, the non-competitive inhibitor decreases the maximum velocity of an enzyme reaction without affecting the Michel's constant. So non-competitive inhibition therefore cannot be overcome by increasing the substrate concentration. Whereas the previous one, we can overcome this competitive inhibition by increasing the substrate concentration, but the non-competitive inhibition cannot be overcome by increasing this substrate concentration, because this inhibitor can bind to a free enzyme or to enzyme substrate complex, and as it is not having any effect on the active site. Okay, so that's how the increase in the substrate concentration does not affect this non-competitive inhibition. So this is the second type of inhibition, that is non-competitive inhibition. Remember, in the non-competitive inhibition, the non-competitive inhibitor can bind either to a free enzyme or to an enzyme substrate complex, and it is going to bind to the other than the active site. So remember this one, because in the next uncompetitive inhibition we will read that difference. So here is the difference between the competitive inhibition and the non-competitive inhibition. At a glance I want to show you. So here is our enzymes. Okay, in the competitive inhibition, if you see, the substrate and the inhibitor are possessing the similar type of the shape, and these two are going to fight or compete with one another to occupy the active site of the enzyme. What is this site? It is going to be some other site other than the active site. Now what is happening here? Inhibitor is going to occupy this place. So obviously if inhibitor binds to an enzyme, so there will be no reaction. So directly blocks the active site, and that's all, no formation of products. Then coming to the non-competitive inhibition, where there will be no competition between the substrate and the inhibitor. See here, two altered shapes of a substrate and the inhibitor. So now this inhibitor is going to bind to other side, leaving the active site. Now the active site can be binded by this substrate molecule. So that's why I told you here it can bind to either the free enzyme or with the enzyme substrate complex. Okay, so obviously whatever it may be, this active site shape is going to be changed because of the conformational change occurs due to this inhibitor, and there will be no product formation. Okay, so that's how it is going to inhibit the enzyme activity. And then moving to the third type of inhibition, that is uncompetitive inhibition. So it is a reversible inhibition, so we can bring it back. In this, the inhibitor binds to a different site from the active site of an enzyme for the substrate. And uncompetitive inhibitors binds only to the enzyme substrate complex. So remember, the uncompetitive inhibitor binds only to the enzyme substrate complex. So that means, whereas in non-competitive, I told you it can bind either to a free enzyme or enzyme substrate complex. But in the uncompetitive inhibition, you can observe here, this type of inhibitor is going to bind only to the enzyme substrate complex. It cannot directly bind to the enzyme, okay, free enzyme, though it is not binding at the active site. An uncompetitive inhibitor acts by decreasing the turnover number rather than by diminishing the proportion of enzyme molecules that are bound to the substrate. This uncompetitive inhibition, in contrast with the competitive inhibition, cannot be overcome by increasing the substrate count. That's what I told you. Whether it is a non-competitive or uncompetitive inhibition, it cannot be overcome by simply increasing the substrate concentration, which will happen only in the competitive inhibition, because the substrate is more actively bind to the enzyme in the presence of inhibitors. And this uncompetitive inhibition is a hypothetical case, it's not practically proven, so that's why it is not going to have discussed more in the many of the books. But we are supposed to have this uncompetitive inhibition will bind only to the enzyme substrate complex and not to free enzyme, whereas in non-competitive inhibition, that is the second type of non-competitive inhibition, this inhibitor will bind both to the free enzyme as well as to the enzyme substrate complex. But in uncompetitive inhibition, what happens? The inhibitor will bind only to the enzyme substrate complex. So this is what you have to remember between the difference between your non-competitive and the uncompetitive inhibition. Then moving to the fourth type of inhibition that I told you is allosteric inhibition or feedback inhibition or end product inhibition, which is also called as suicidal inhibition. Okay, so it is one in which the end product of the reaction, so feedback inhibition, end product inhibition, factors affecting, I told you, product, the more accumulation of the product will stop the enzyme activity, isn't it? So here comes the end product. So for example, if your enzyme, you are going to take the different enzymes participating in a metabolic reaction. So A is being converted, this is a substrate A, which is being converted into B with the help of an enzyme called as enzyme 1. And if B acting as a substrate and converting into C, where enzyme 2 is involved, and the C is going to give rise to the D with the help of an enzyme 3. Okay, now there is a more accumulation of this D compound, that is a product is going to be accumulated more in the cell. Now what happens? This product is going and binding to the enzyme 1, and that's how. What happens if the enzyme 1 is going to be blocked? The substrate A cannot be converted into the that is B product, and now this cannot give rise to the further reaction, and that's how, as the product is involved in stopping the enzyme activity, we call this as end product inhibition, as it is a feedback. So it's telling that more accumulation of the product is there, so you are supposed to halt for some time or stop for some time to the enzyme. So obviously this is a feedback inhibition, and here it is also going to occur other than the active site. We call it as allosteric type of inhibition. So that's how it is one of the type in which the end product of the reaction acts as an inhibitor and inhibits the activity of regulatory enzyme. If a reaction is proceeding in several steps and the product of first reaction is a substrate for another reaction, I told you, and then each step is catalyzed by separate enzymes. The end product of reaction accumulates and binds with the enzyme catalyzing the first step to inhibit the process. So such as kind of inhibition is being called as feedback inhibition. Okay, so as a product is involved in the inhibition of the process or enzyme activity, we call it as end product inhibition. So that's how we have discussed the 4 types of inhibitions. Okay, so one is a competitive, non-competitive, uncompetitive, and another one is the allostatic. So let's have a just quick overview or review of the inhibitions that we have discussed. So in the competitive, I told you structurally substrate and the inhibitor are structurally similar in nature, and they both will compete for occupying this active side of the enzyme. So if the substrate is going to bind, we will get the product. If inhibitor is going to bind, we won't get the product, and that's how the enzyme activity is going to be inhibited. Then coming to the non-competitive inhibition. So here the active side is free, the substrate can obviously come and bind, and this inhibitor can bind to a free enzyme or it can bind to an enzyme substrate complex, and that's how it is going to stop or inhibit the enzyme activity. So here you can see this is a normal reaction in the formation of a product. So the inhibitor can bind at the free enzyme state forming the enzyme inhibitor complex, or it can bind to an enzyme substrate complex, and where it is forming the enzyme substrate inhibitor complex. In both the cases, it is going to stop it. And here coming to the uncompetitive, so here you are going to have the active side here also free, so the substrate can come and bind, and after that only this inhibitor will come and bind to this enzyme substrate complex. So here you can see, so neither it is not combining with the free enzyme, so it will bind, the inhibitor will bind only to the enzyme substrate complex. So that's how it is going to, after coming and binding to this one, we call it as enzyme substrate inhibitory complex, and that's how it will stop the or halt the or decrease the enzyme activity. So this is the step where it differs between the non-competitive inhibitor can bind either to the free enzyme or enzyme substrate complex, but the uncompetitive inhibitor will bind only to enzyme substrate complex. Okay, so this is how we have discussed about the 4 types of enzyme inhibition. One is our competitive, non-competitive, uncompetitive, and one more is the feedback or end product inhibition. Okay, so it's a very important topic in the enzymes chapter. Okay, thank you.